today we're dividing. So yesterday was multiplication. Monday was adding and subtracting. We're doing all the operations. Your test on Tuesday over radicals is 17 is just like simplifying the radicals, rational exponents, all just no operations. 18 is add, subtract, multiply, divide. Okay, so we're going to finish that up today, tomorrow, and then we'll review Monday, test Tuesday. You can have no more roots that can be factored, meaning that you can't split up any of the radicals any further. That's how you know you're done. Also, the radicand's not a fraction. Can't have that. Also, you can't have a radical in the denominator. That's how you know you are done, okay? Okay. So we're going to look at this first guy here, and we're going to simplify over and over and over. You're going to see me write again and again and again. But just because I'm trying to do one step at a time only, which I encourage you to do the same thing. Don't try and do it all at once. It's a bad idea. Okay. Let's look here. We look at this right now. We have the cube root of all of that. Yikes. 2 over 54. Can you simplify that? Is there anything they both divide by? 2. Okay, so we want to do that. We can simplify that. Since they're both inside numbers, we can divide them to each other. We're inside numbers to inside numbers, outside numbers to outside numbers. These are both inside. So that would be, what is that? 27, right? Okay, so 27, and the top number would be 1, which doesn't really do anything for you, so it's just x. Okay, do you see what I did? There's one step. Now, when we don't like this, the cube root of a fraction, no sir. We need to split it up, and so it's not the cube root of a fraction. So it's the cube root of x over the cube root of 27. Still not much better because you don't want to have a root in the denominator or a radical of the denominator. But check your perfects chart. What do you know about 27? It's a perfect cube, right? And the cube root of 27 is 3. Ta-da! Okay. And so you would also check this numerator here and see, okay, can I simplify that? Because that's how you know when you're done, right? It's x to the first. Can 1 divide by 3 at all? Can 3 go into 1? Nah, he's stuck. So in the numerator, you're just going to leave it as cube root of x. And that's as far as it goes. So you would check the things. Can I split up the radical any further, the one that's left over, the x? Nope. Is my radicand a fraction? Do I have a fraction inside a radical? Nope. Any radicals in the denominator? Nope. So I'm done. You got to check all those things. Questions? Okay. So division, you're just looking to see, okay, top to bottom, anything I can simplify. And the big thing is you can't have a root in the bottom. Oh, there's a check mark this side. Yes, we simplified it. You would check the box. It's in simplified form. It's just for you to check all the boxes. What is it? The 21st? Is that right? We're off on Friday. We have an early release on Thursday next week, right? Okay. All right, let's look here. These are not in the same radical, but it's okay. We can go ahead and look at them. Look at the numbers first, okay? We're just looking to see anything we have top to bottom that we could reduce and make a little bit less terrible, okay? 17 divided by 2. They're both inside numbers, so fair game. Or 17 and 2 both divide by 2. So what do we get? 36, right? Okay. And here's the beautiful part about that. When you do it, it would be 36, and then we square root of 1 on the bottom, which is, going to do nothing. So you notice that the denominator actually goes away. Yay. Okay. And we simplify what's left. What do you know about 36? Yeah, it's perfect, right? When you take the square root of 36, you get 6. Good. Okay, so equals 6. What about this? What's my index here, by the way? It's 2, because it's a square root. So take the exponent and divide by 2. Does that work out for me? Yes, beautiful. Okay, so it's x to the first. Because x times x is x squared. The square root of x squared is x. Do I really need the x first? No, you could just write it as 6x, but it's fine. It all means the same thing. And then we would check and make sure you've done all the things at the top of the page. It said, so do we have any more roots to break apart? To be factored? No. Do we have any more fractions in the radicand? Do we have any radicals in the denominator? No. So we're done. Great news. Okay, so you could check this box over here that says simplified form. Yes. Okay. Uno más. Here, and then we're going to get to something that's a little bit weird here in a second by accident. Okay, 3 over 21. They can both divide by?
3.
3. Okay, so rewrite it. So that'll be 1x in the top, or just x, and 7. Okay, do we want a fraction underneath the radical? No. So you're going to break it apart so you have 2 separate roots. Like that. Okay, and this is where it gets a little dicey because we would want to check and say, okay, can I do anything here? Square root of x the first, can 1 divide by 2? No. Can square root of 7 divide by any perfect squares? No. Shoot. Okay, but check the third thing on your list. It says no square roots in the, or no radicals in the denominator. Okay, which is what you currently have. So that's a no. You need to now get rid of that. This is the square root of 7 to the first. If I want to make the squared, the exponent, and the index cancel each other out, then these need to match. Need to match. I'm talking about the index and the exponent. That would cancel them out. And so if I have 7 to the first right now, how many more do I need? I need 1 more, right? And so I can multiply by 7 to the first, which is just 7. So this is called, what we're about to do is called rationalize, which you might remember doing in geometry. We did it a little bit in the fall as well with eyes. Rationalize the denominator. That's what we're doing. Denominator. A big word. Okay, that is what's happening. Okay. Great. So insides can multiply to insides. You can multiply these two things together. X and the 7. So it's going to be square root of 7x. And in the bottom, you're multiplying square root of 7 times square root of 7, which is square root of 49. Or another way to think about it, it's the square root of 7 squared, because you would add your exponents, okay? And that's why this is going to cancel out in a second and get you down to 7. What is the square root of 49? It's a perfect, right? And so it's just 7. And so you get equals 7. And in the numerator, you have square root of 7x. Can I divide the 7s? You would think that you could, but you can't because one's inside and one's outside. They are not friends. You cannot do this. No. Okay, so I'm pretty sure that's it. Yeah, that's as far as it goes. So then you would check, okay, can I break apart that top radical anymore? Don't think so because it's 7 to the first and that's squared. Do I have any radicals in the denominator? No. Do I have a square root of a fraction? No. So we're fine. Okay, so what you just did was rationalizing the denominator, and we're about to do it 2 more times, okay? So let's answer this question here. So what happens if we have a denominator in the radical? Well, we got to take care of it, right? So if we have a denominator that has a radical, I said that completely wrong. Okay, you're going to multiply the numerator and the denominator by the radical. Numerator, that's the top, and the denominator by the radical that clears the radical from the denominator. So it's got to clear it out. So if you look at what we just did, we were like, okay, if I had 7 to the first, I need one more. So when I multiply that, it got me 7. It got rid of the radical in the denominator. We're going to do 2 more here. If you want to flip to the next page, so we'll do 16, 17, and then we'll save 18 for what, tomorrow, okay? So dividing by a monomial. So when you have a monomial in the denominator, meaning one term, then you're going to have to rationalize the denominator on each of these, okay? But before we get started, we want to simplify things as much as we can so it's not terrible. So if you want to look at these two, I can't do 2 divided by 32 because 2 is outside, 32 is inside. No. But you can simplify 32 because you check your perfect chart and there's a perfect square that 32 divides by, friends. What is it? Yeah, 16 is the perfect square. 16 times 2. And so I'm just going to go ahead and rewrite this. We're rewriting in baby bits so that we don't get completely lost, okay? Rewriting the top. I mean, it's confusing enough as it is. We're not trying to do lots of steps at once. So negative 2x stays. And the square root of 16 is 4. 4 root 2. We already chatted about how you can't divide the 2's because that negative 2 is outside, the other 2 is inside. But do you see a different thing you can simplify? Yeah, the 2 and the 4, right? Because those are both outside numbers, you can go ahead and, they're called coefficients, not outside numbers. We're just trying to say different words. Yeah, coefficients, we can simplify that. So reduce it. That would become 2/4 becomes, divide by 2, 1/2. So if I divide by 2, that becomes 2 root 2. Okay, so things are looking a little bit better. The problem is that you still have a square root in the denominator, and you're not allowed to have radicals in the bottom of a fraction. And so you have to simplify that. You right now have a square root of 2 to what power? 2 to 1, which means you need these to match. How many more do you need? 1 more, okay? So I'll do that in red, actually. So I'm going to multiply by 1 more 2. And I can't just do that to the bottom because that's not keeping it equal. You need to make sure you multiply top and bottom because then you're multiplying by 1. Square root of 2 divided by square root of 2 is just 1. So that's your 1 extra 2 that you're multiplying by. And so we would multiply straight across. We multiply fractions. You cannot multiply the x and the 2 together in the top. The negative x stays out in front, like that. And then here on the bottom, you have 2. Okay, and then it becomes the square root of 2 times 2? 4. But you know what that is. What is it? So if you can start doing some of this stuff in your head while you're working it out, that's great. 2, square root of 4 is 2. 1 more time. Here we go. Write it out one more time. So what would that be in the denominator? 4, right? Okay, and then you would just check and see, okay, do I have anything on the outside that can simplify? Because 4 is an outside number. Well, no, because it's just -1, right? So that's as far as it goes. So you just double check and make sure you've done all the things. Can I break apart square root of 2 any further? No. Any fractions under the radical? No. Any radicals in the denominator? No. Okay. Okay, last one because we need to do one more type that's not a square. Because we've done all squares, I think, so far. This last one is not. Okay, so the first thing you would check is these two, 5 and 192, are both inside. So we could see, okay, can that divide evenly? Can 192 divide by 5? No, it doesn't end in a 0 or 5. So, no, that's unfortunate. Okay, but 192 is a pretty big number. I would rather not rationalize with 192. And so let's see if we can get this radical to simplify. You could do prime factorization, or you could look at your perfect chart, right? I'm feeling a little lazy, so I'm just going to start dividing by 2 because it's an even number. Oh, what would that be? Think about it. 96? Sorry about that. Okay, so 2, since it's even again. 48. I should have written smaller. 24, also even. 12, also even. 2, 6. Glad I wrote so big. What will come next? 3. 3 is a prime number, so it divides by itself. Wow, look at that. That was special. Okay. Which tells me, okay, it's a cube root, so I'm looking for groups of 3, right? There's 3. Here's another set of 3. So if I'm going to do it like this, then I would say, okay, it's going to be 2. So that's from the first set. 2 again. And then the leftover one is what? 3. Yeah, and so it'd be root 3. This is a lazy man's way of dealing with roots, which is fine. I'm all for it. Okay, so 4 times the cube root of 3. Another way to do it, right? That tells you then the perfect cube that this divides by is 64. 64 times 3. So same idea, right? It would get you 4, and then the leftover would be 3. Okay, whew, all of that to just try and rewrite it before we get to the really ugly part. Okay, cube root of 5 is still in the numerator, and in the denominator you have x. It's not x to the third, by the way. That 3 is the index. And then we are going to rewrite it. Actually, let me fix this. It's 4x times the cube root of 3. Yes? Okay. Can I reduce this? 5 divided by 3? Nah. It's stuck. And so we're going to go ahead and rationalize, which means that we're comparing. We got to get rid of the square root or the cube root in the denominator. It's a cube root of 3 to the first. Okay, if it's 3 to the first, I need these to match. I'll point it out again. The index and the exponent need to match. If you have 1, how many more do you need? 2. You need 2 more. So what I'm going to use is I'm going to use the cube root of 3 squared. Do you see that? Because then it would be 1 plus 2, 3. Cube root of 3 squared. When you go to do that, this is not going to be very pretty, but I'm going to rewrite it lots of times. Cube root of 5 times the cube root of 3 squared is 9, right? Just leave it like that for now. And in the denominator, I now have 4x. It's the cube root of 3 to the third. Do you know what happens when you have cube root of a cube? They cancel out. So these are gone. And you're just left with 3. That's because this is 27. 3 to the third. Okay, cube root of 45 over, gross. 4x times 3. Man, it's like the problem that just never ends. And the cube root of 45 over 12x. That's as far as it goes, I believe. You're just rewriting it again until there's nothing else you can do. And you would just check that. Okay, 45, does it split any further? It's a cube root. No. And so, because it can't divide by 8 or 27. So you're as far as you go. Woof. Okay?